Hello. Good afternoon, everyone. Thanks for having me. Very lucky to be the last one. My name is Zoey. I'm from Monash University, and as you can see that my research topic is using blockchain in education and recruitment. So why this particular focus? Simply because before I start my PhD journey, I used to work in the education and training industry for about 10 years. Wearing different hats, from like curriculum designer to a startup owner, and I found out there's so many problems in the traditional education industries. So I've been keeps on thinking, what's the purpose of education? What are we aiming to achieve, right? So maybe from the society's perspective, we're just trying to cultivate people, providing the suitable workforce for the companies. And from the individual learner's perspective, they just want to find the job that they are good at or they feel passionate about. But what's the reality, right? It's definitely we haven't achieved our original goal. So now Web3 is coming and technology are accelerating every day. But we still use that very old way to educate people. That's not going to work. So that's the reason why I think this topic is worth to dive into. So in today's talk, I will just quickly cover two parts. The first part, we will quickly go through our research outcomes in the past 2 years, which is going to including how we develop a D-app, education credentialing system, and how we generalize the whole development experience into a D-app engineering approach for higher adoption. And then we're going to cover what security properties we're trying to achieve in our newly proposed credential scheme. And the second part of today's talk, we're going to look into the future to see what the future education landscape will look like when it can be empowered by blockchain and AI. So the social challenges I've just mentioned a little bit. Our enterprises are facing challenges. Just imagine you are an HR officer and you're looking for some talent for your company. Where are you going to? You probably go to LinkedIn or Seek or some similar platforms. But once you realize that there were 700 million LinkedIn users' data has been sold on the dark web, can you still trust the people that you just find online? How can you tell they're providing you with the authentic education history or not? So that's the reason why our enterprises have to increase their recruitment budget each year. And from the individual learners' perspective, they're also facing lots of challenges, right? They're becoming harder to certify who they are and what they can do, but they still have to put their learning profile, their employment history on those recruitment websites because they have to prove them their ability. And then they have zero control over their own data. So facing those challenges, there's a promising solution, and we call it self-sovereign identity, short for SSI. So what is SSI? It has the following key attributes, namely the user can have full control over their identities, and they only need to review minimal data disclosure in order to satisfy the verification purpose. And also it is usually supported by decentralized data storage. So just for simplicity and clarification, we draw these pictures for everyone to understand. At the bottom layer is the distributed layer, usually secured by the blockchain technology to ensure the immutability and transparency. On top of that, it's a decentralized identifier, which layer will identify each user's identity and roles uniquely. And on top of that, anonymous credentials. This is where the credential creations, issuance, management, and verification happens. And on the top layer is the application layer. And this is directly interacting with the users. So how can we get started? It seems quite complicated, so many layers, right? And we decided to take the top-down approach. Why is that? Because our academic, we are academic people, but we want to make sure this is not only an academic outcome, but also can be a product that can be accepted by our users and the society. So, of course, as a research, we have to go through a lot of the research gaps. So those are the limitations. the current research outcomes, they either stay at the prototype level, or some of them probably become a product, but they tend to show very low usability and adoption rate. So that's the reason why we intended to involve more systematic user involvement strategies in our study. And technically, most of those SSI systems are partial decentralized, so we cannot call them a complete SSI system. So, our contribution. So focusing and targeting those limitations, in the past 2 years, we published 3 papers, and each paper is trying to solve 1 to 2 limitations. And we will cover some key points in the following slides. So as I mentioned, we want our system can be adopted by the society as well. So for a product to be very well received by the market, it has to do 2 things well. Firstly, it needs to bring customers superior values, and secondly, it should be very well defined. So that's the reason why we didn't step into the system design and the development straight away, and we start from the industry investigation. And we conducted industry investigation from the recruiters who are verifying those certificates. So as you can see that, we interviewed 12 employers, senior employers from different industries. And most of them have the working experiences more than 10 years. And some of them are from the stock listing companies in China, Australia, and UK. So we want to know what are their attitudes toward the certificates, and what is the concurrent recruitment processes, and how they verify those credentials. So after gathering all these data, we try to analyze these data. We analyze the data in 2 ways. Firstly, we use the process mining skill to generate this BPMN model. So this model, you probably couldn't see it very clearly, but the purpose of this figure here is to show you how many verification and screening steps in the concurrent recruitment procedures. And usually, the duration is from 3 months to 6 months, depends on the positions. So the higher the position they are recruiting, the longer the time it's going to take. And also, we analyze the data through the thematic coding using NVivo system. And we generalized top 5 verification challenges. So our recruiters, they're actually complaining that we don't want to spy into the candidate's privacy and history, but we don't have other choice. We don't have better alternatives in order to understand, to figure out whether the candidate is a suitable one or not, whether they are telling the truth. So they have to do that. And 100% of our recruiters, they mentioned that they have met the fraudulent behaviors before. And after these many steps of verification and screenings, can we get the very trustworthy verification result? And the answer is still no. Because our recruiter said the verification result is still largely depending on their personal judgment and their experts. So after understanding our credential verifiers, we also try to understand our learners who are pursuing the credentials, who are managing and using them. And we define a customer value matrix in order to gather and measure their requirements and their pain points. And we defined this matrix very comprehensively in our paper, but here I only present the statistical result. So I think I might not really have time to go through all of those statistical figures, but the conclusion is the learners, they're also very concerned about their privacy linkage. And a majority of them, they really believe education certificates can bring them values when they're finding a job. So after understanding our stakeholders, we start to design and develop the system. And we have 4 entities and also 4 functional modules. Regarding the implementation code, I put the GitHub link here. And also for the technical details, please check out our full paper. I also don't have time to go through them today. We also did the performance testing. But here, today's focus is more about like how we involve the learners and the recruiters, verifiers. So we're currently providing 2 dashboards. One is for the recruiters to create and issuing the credentials, and another dashboard is for learners. They can manage and share their credentials. And we use this CValid.org, this credentialing system, to issue the Monash summer school certificates last year. So for those participants who claimed their blockchain certificates online through our system, they can actually hold it either in our system or they can hold it within their blockchain wallet. So we also did the usability testings in 2 ways. Quantitatively, we use the SUS analysis, like system usability scale, to assess the usability of our system. And qualitatively, we adopt the social technical grounded theory, this framework for analyzing the data. So, and we generalize lots of the user feedback, and we categorize into 3 groups, namely the blockchain relevant feedback, system realization, and user experience. So after this many work of involving our users in the whole design and development procedures, we finally generalized the whole experience into this framework. And we call it blockchain-oriented software engineering approach for higher adoption possibilities, BOSHAP. Even though there are already some DApp engineering approaches, but most of those studies, they simply focusing on assessing the blockchain feasibilities. And they just simply adapt from the agile approach. But our approach, as you have heard about that, we actually build on the social technical grounded theory, and we have very systematic user involvement. So we believe that it can help our DApp to achieve better social adoption. So there were 2 remaining questions after gathering all of those user feedbacks. And one question is, how can some of the users, they actually mentioned that we want to prove ownership of the credentials, but we don't want those education certificate to review anything about my identity. So how can we achieve the selective disclosure of credentials while still ensuring the user's privacy and satisfy the verifier's verification needs? So that's actually one question. And the second question we're always being challenged is how to ensure the credentials can really reflect the learner's educational achievements. So these 2 questions actually leading us to 2 directions of work. In order to answer them, to answer the first question, we actually proposed a decentralized anonymous credential scheme this year. And this scheme can satisfy the following security properties. So firstly, our credentials are issued based on the eligible attributes of the users. So users, they can just combine different attributes and generate more context-based credentials. And they can use it in different scenarios. And secondly, it supports anonymity and unlinkabilities. And these 2 words are quite straightforward. But unlinkability and anonymity can always be misused by some malicious users, right? So how can we prevent that? So that's why we have to involve the revocation functions as well. So when the credentials are compromised or misused or probably just accidentally lost, the users, they can just recall the credentials or they can just invalidate the previous issued credentials. And lastly, is also the most importantly, is our feature. We have achieved the selective disclosure, which means that even though those credentials are unlinkable, but the users, they still have a way to subtly link them together if it is necessary. So on the right-hand side, this figure shows how we integrate the DAC scheme into a blockchain credential system. But this paper, we haven't published yet. So I wish in the future I still got the chance and opportunity to share with you. And in order to answer the second question, how to ensure the credentials can really reflect the learner's educational achievement, in order to answer this question, firstly, we have to know what is a good education outcome. So here I have to introduce a very well-known education theory, and we call it zone of proximal development, short for ZPD zone. So the ZPD zone is the zone in the middle between what the learner can do all by themselves and what the learners cannot do, even with lots of help and hard working. So a good learning always happening within this ZPD zone. So how can we make sure the teaching and the learning always happening within this ZPD zone? Traditionally, it depends on the teacher. So if the teacher is very experienced, if the teacher has more knowledge of the students, and the teacher can better deliver the teaching within this ZPD zone. So we believe that in the very near future, AI can play this role. AI can play the role as an experienced teacher. How can do that? So let's go through this diagram. I just drew this diagram a few days ago. So when the students, they raise up a question, starting from here, that's a prompt, and then the AI-empowered learning system can go through a very large content library and searching for the relevant learning content, as well as the student's history performance and the student's last round of the ZPD. And then the reasoning machine, the reasoning engine, can analyze the student's input as well as the student's history performance and the last round of ZPD in order to decide the student's next round ZPD. Okay, and then in the retrieval stage, the system will just retrieve those content, those curriculum that can fall into the student's ZPD zone. And then all of those learning materials will be presented to learners through the learning tools, maybe some like learning software or some virtual classroom or labs. So in this way, the AI can generally adjusting the content and by interacting with the learners and learn about the learners and can gradually make sure that the teaching and the learning can fall into the student's ZPD. So you might ask another question is, okay, because we know that AI model is training based on a lot of data, right? So we have to feed the AI model using the students' learning data. That's a lot of students' learning data. So how can we ensure and safeguarding the students' privacy and learning data, right? So that's the problem we were trying to solve in our previous decentralized anonymous credentials. So that's a full circle now. So far, I involved a lot of concepts, right? Lots of concepts, including like some education concept as well. Sorry about that, but it's quite an interdisciplinary study. So, and all of those preliminaries are acting like the building blocks of the future education blueprint. And let's give it a beautiful name. We call it decentralized learning autonomy. So the learner, they have the full control over their own learning. So in this journey, the AI support learning can ensure the quality of the students' learning output. And the whole procedure, maybe the students will achieve some milestones or some micro-credentials, and those achievements, educational achievements, will be secured by the blockchain-supported credentials. And in later stages, when the students, they want to look for a job or in some other social context, they can just selectively link the previously credentials to generalize a verifiable CV or resume. So in this way, our recruiters do not need to go through the traditional way of recruitment and verification screening. So our recruiters, they can just strictly need to trust the presented CV by the learners because it was already safeguarded by the whole system. So as you can see, this is a very high-level idea. I still have a lot of remaining questions. So that's why we're also looking for collaborations. If you're interested, please drop me an email. So I put it at the corner as zoey.li@monash.edu. So that's our references. Thank you very much.